Sunspots are temporary phenomena in the sun's photosphere that appear as spots darker than the surrounding areas. They are regions of reduced surface temperature caused by concentrations of magnetic field flux that inhibit convection. One such sunspot, active region 3842, has recently garnered significant attention due to its powerful solar flare on October the 1st, 2024. This sunspot, active region 3842, is a particularly active region on the sun's surface. On October the 1st, it released an X7.1 class solar flare. This is one of the most powerful types of solar flares. This flare was significant, not only for its intensity, but also for its potential impact on our planet. The X-flare caused immediate shortwave radio blackouts over the Pacific Ocean, indicating the immense energy that was released. The X7.1 class solar flare from the active region 3842 released a tremendous amount of energy. Solar flares of this magnitude are capable of releasing energy equivalent to billions of atomic bombs exploding simultaneously. Astronomers say that this energy is primarily in the form of electromagnetic radiation, including X-rays and ultraviolet light. The flare also likely produced a coronal mass ejection, known as a CME. This is a massive burst of solar wind and magnetic fields rising above the solar corona and being released into space towards our planet. When the energy from this sunspot interacts with Earth's atmosphere on October the 5th, several effects are anticipated. The interaction of the coronal mass ejection with Earth's magnetosphere can induce geomagnetic storms. These storms can disrupt satellite operations, GPS systems and power grids. The intensity of the storm will depend on the strength and orientation of the CME's magnetic field. One of the more visually spectacular effects will be the auroras. These can occur when charged particles from the CME collide with atoms in Earth's atmosphere, causing them to glow. Auroras are expected to be visible at much lower latitudes than usual due to the strength of this coronal mass ejection. This event is expected to cause radio blackouts. High frequency radio communications can be disrupted by the increased ionisation in Earth's ionosphere caused by the solar flare's X-rays. This can affect aviation, maritime and emergency communications. Another effect of this event is radiation hazards. Increased radiation levels can pose a risk to astronauts on the International Space Station and in space, and passengers on high altitude flights, particularly near the poles. Airlines may need to reroute flights to avoid these areas during the peak of this storm. The solar flare from sunspot AR3842 on October the 1st represents a significant event in solar and space weather. The energy released by this flare and the subsequent CME will have notable effects on Earth's atmosphere, ranging from geomagnetic storms and auroras to potential disruptions in communication and navigation systems. Understanding and preparing for these impacts is crucial for mitigating their effects on our technology-dependent society. By studying events like the solar flare from the active region 3842, scientists can better predict and prepare for future solar activity, helping to protect our planet and its technological infrastructure from the sun's powerful and unpredictable behaviour. But what do you guys think about this? Comments below, and thank you for watching.